The next type of problems that we're going to be doing involve transferring heat from one thing to another thing. But before we begin, I need to share some terminology that'll be important for this unit.
And that is the difference between system and surroundings. Okay, the system, let's not cross things up. The system is basically everything you care about. And the surroundings are basically everything else. Okay, so I have a little artistic rendering here of ice floating in water. Okay, so I want to know what's going on with the ice. So in this case, the ice would be my system, and the water, the air, everything else would be my surroundings. Okay, so now my question is here, let's finish this sentence. Heat is lost by blank and gained by blank. Okay, so in this case, heat is lost by the water. The water is going to lose heat and the ice is going to gain heat. Okay, so heat is lost by the water, and since I said that the water are the surroundings, I can say the heat is lost by the surroundings and gained by the system. Okay, so let's take this a little further. What is the sign of heat of the system? And what is the sign of heat of the surroundings? Okay, so why don't you pause and see if you can figure that out. Okay, so Q system is the ice cube, right? And Q surroundings is the water. So the water is decreasing in temperature, which means that it is going to have a negative delta T, so it's going to have a negative heat associated with that temperature loss. So that heat must be being gained by the system, the ice, so that's going to increase. And if I wanted to make a mathematical relationship, based on conservation of energy, I know that any heat lost by the surroundings must be gained by the system. Okay, so that's Q system equals negative Q surroundings. Okay, so there's just a little terminology that's used a lot in thermochemistry, the system and the surroundings.